This comparison highlights the central promise of the supersonic revival, cutting the transatlantic flight time from New York to London down to about 3.5 hours. Aviation engineers solved this speed problem back in the 1960s with the Concorde, but the last time civilians were routinely outrunning the speed of sound, the streets of London looked like this. It has been decades since a traveler could buy a ticket for a supersonic flight. The first supersonic era ended with the Concorde's retirement, leaving a vacuum in global travel. It revealed a specific physical hurdle that has kept commercial flight below the speed of sound for over 20 years. That hurdle was the sonic boom, a noise profile that proved too disruptive for people living under the flight path. A sonic boom isn't a one-time event from the engines. It's a continuous shockwave. When a jet outruns its own sound waves, they compress at the nose to form a dense, trailing cone that drags across the landscape for the duration of the flight. The public reaction was intense enough to trigger a regulatory shutdown. Lawmakers implemented a strict ban that has now lasted 53 years, making it illegal to fly at supersonic speeds over land. For airlines, the ban was an economic dead end. It is difficult to turn a profit on a high-speed jet that is legally required to fly at conventional speeds every time it crosses a coastline. Resurrecting these routes depends on airframe geometry as much as engine power. Engineers have to reshape the aircraft itself to appease modern noise regulations. NASA is currently leading a government-backed initiative to find a physical solution to that noise problem. This is the NASA X-59. It is a research prototype built to prove that a jet can break the sound barrier without the explosive noise. This technical breakdown highlights the aircraft's defining feature, a 38-foot nose. The extreme length physically separates sound waves before they merge into a single violent shockwave. If the design works, that sharp crack is reduced to a quiet thump, the necessary standard for overland flight. The X-59 is a data collection tool rather than a passenger jet. Its purpose is to generate the evidence Congress requires to see that quiet supersonic travel is possible. The schedule is tight. Critical deadlines are approaching in 2026 for both the X-59's flight tests and a formal congressional review. As this panel shows, these two events are linked. The flight tests must provide the hard data needed to successfully challenge that 53-year ban during the March review. Private companies are banking on a favorable ruling. Boom Supersonic is currently developing the Overture, a commercial airliner designed to carry up to 80 passengers. Major carriers are already committing to the technology. Japan Airlines is among legacy companies contributing to a backlog of roughly 130 orders. With NASA addressing the physics and airlines providing the capital, the optimism surrounding a supersonic revival seems well-founded. However, the plan faces a separate challenge within the supply chain. Transitioning from a single-seat research jet to a profitable daily airliner introduces hurdles that go beyond aerodynamics. The most immediate issue is the volume of fuel required to push a passenger cabin past the speed of sound. Because of industry-wide carbon mandates, these jets cannot use standard kerosene. They are being designed to run exclusively on sustainable aviation fuel, or SAF. This reality check panel points to the bottleneck. Sustainable fuel is currently scarce. Global production is not yet high enough to support a full fleet of supersonic airliners. Engineering a quiet airplane addresses the physics, but without a massive infrastructure for green fuel, commercial flights cannot scale. This creates a gap between the 2026 test flight headlines and the logistical requirements of a global rollout. When accounting for manufacturing and fuel supply, the timeline for when consumers can actually buy a ticket is more realistically a 2030 story. This extended lead time represents the careful, methodical process required to safely resurrect an entire commercial sector of aviation. The physics of quiet supersonic flight have been conquered. The transition to commercial service is now a matter of industrial scale.